Hello everyone. In this lecture, we will be solving GATE question which was asked in 2014, and the topic is CPU scheduling, which comes under operating system. Right? The question here is we are given 5 processes A, B, C, D, E, and along with these processes, their arrival time as well as burst time is being given. Arrival time is the time when the process has arrived into the system, and burst time is the total time taken by the process to complete its execution. Right? And the algorithm that we need to apply here is shortest remaining time for scheduling algorithm, and it is based on SJF. So SJF has two versions: preemptive SJF and non-preemptive SJF. Now here the version that we have to do is preemptive SJF, and here we have to bring that process into the CPU, which will take less time to execute. Right, and finally we have to find out the average process turnaround time. Okay, and these are the 4 options, out of which one is correct. So now let's solve the question. Yeah, so as you can see from here in this question, we have been given these 4 processes, 5 processes, naming A, B, C, D, E, right? And now we will solve them one by one. Now see, the first process is A, and it has arrived at 0th millisecond, and there is no other process who has joined the CPU. So at the 0th millisecond, though the burst time of this process is high as compared to the other processes which are having lesser burst time, but the thing is, if there is no one available, then obviously A will take its turn. Now A has taken its turn, and it will be in the CPU for the next process to join, and the next process will join at 3rd millisecond. So till then, this will be running into the system. So 0 plus 3 is how much? 3. So it will be running for next 3 milliseconds, right? So 6 minus 3 is 3. So the remaining time left for this process is 3. Now, at this particular time, who has joined the CPU? The process which has joined the CPU is A was already there, but now B has also joined. And the burst time of A is 3, and the burst time of B is 2. And out of which this is minimum. So we are now going to bring this B into this CPU. Okay. So let's pick it again, and I pick here B. Now B is going to run for how many seconds? Milliseconds. So we know that the next process will join at 5th millisecond. So this process B is going to run for next 2 milliseconds, and then we will decide whether this has to continue or some other process will join. So 3 plus 2 is 5, right? So now 2 minus 2 is 0. And it says that now this process has completed its execution. So it is no more there in the ready queue for waiting its turn. Now, here, if I talk about the 5th millisecond, as we can see here, in this, the process which has joined the ready queue is, we already had A, right? Now we also have with us C. So C has also joined. The remaining time of A is 3, and the remaining time, the burst time of this C process is 4, out of which this is minimum. So now A will take the CPU, and A is now into the C system. It has taken the CPU. Now, here if I talk about this, how long it is going to run? The next process is going to join at 7th millisecond. So this process will be in the CPU for next 2 milliseconds, and then later on we will decide whether it has to continue or not. So A will be in CPU for next 2 milliseconds. 5 plus 2 is 7. So here 3 minus 2, we are left with 1 millisecond. At this point of time, who has joined the system? So we already have A, right? And then the C was also there. Now D has also joined, right? And what is the burst time of all this? A is left with 1. C has a burst time of 4. D has a burst time of 6, out of which this is minimum. So again, A is going to continue. Now again, A will be there in the CPU, and it will run for next 1 millisecond, and then it will complete its execution. So 7 plus 8. So A is continuously available here, right? Now, and what do you mean by preemption? Now, when A was earlier running, but because B has less time to run, it was left with less remaining time. So that is why it preempted A. Similarly, when B was executing into the CPU, but B has completed its execution, and by the time A joined, so A took its place, right? And now after this process has also completed its execution, right? So we are done with this. We are left with only A, D, and E. Now after this, what happens is, at this 8th millisecond, who is with us? Only these three processes are there, right? So at this 8 millisecond, we are having only C. We are only having C, and we will have D. That's it. Because this E will join after 10th millisecond. So C, the burst time of C is 4, and the burst time of D is 6. Out of which is minimum? 4 is minimum. So who will take the CPU? The now CPU will be taken by C, and C is going to continue for next 2 milliseconds, because of 8 plus 2 is 10, and after 10 E will join the ready queue, and then we have to decide out of CDE which is minimum, that will take the CPU. Fine. So 8 plus 2 is 10. So now here let's subtract the timings from here. It is 2, right? Now at this point of time, how many processes we have? We already have C. D was also already there. Now E has joined at 10th millisecond, right? At this second, the E has also joined. What are the timings? C is left with 2, and then D is having 6 burst time, and E is having 3 burst time, out of which is minimum? This is minimum. So this is going to be selected. C is going to be selected, right? So again, C will continue its execution, and it will be 10 plus 2, that is 12. Now C also continued for it was continuously running into the CPU after taking the decision and all. And now at this 12th millisecond, who is there into the system? As you can see from here, at this 12th millisecond, because now C has also completed its execution, B has completed, and which is left, A has also completed. A, B, and C, all of them have completed their execution. So now we have D and E. The execution time of remaining time of D is 6 and E is 3, out of which is minimum? E is minimum. So now we are again going to choose this one, E, right? So I have chosen E here, and what is the time taken by E? 3. So 12 plus 3 is 15. And finally, at this 15 millisecond, we are only left with D. So D will join the CPU, and 15 plus 6 is 21. I hope this Gantt chart is very clear to all of you. Now, what is asked in the questions? The question that is being asked in the question, this gate question is, we have applied preemptive. We have applied preemptive SRTF, that is being applied on this. We can study it from this Gantt chart. Now the next thing is, we have to find out average turnaround time. So I have already uploaded 2 more questions on this preemptive SRTF, and you can see that this is a really very important question, because this question is being asked in GATE exam many times. And not just GATE exam, if you talk about other competitive exams also, it is very, very important. This topic is very, very important. And also in your BTech final year examination also, this question is going to be asked for sure. 100% this question will be there. Now let's find out the average turnaround time. So now, let's find out the average time. So first of all, find out the turnaround time of all the processes individually. So we will find out the turnaround time of A, B, C, D, and E, right? Let's find it out. Now, what is, as I've told you earlier also, what is the turnaround time? Turnaround time is completion time minus your arrival time, right? And in this completion time, your waiting time is also included, but only the arrival time is negated, subtracted, right? Now let's once again do this question. So as you can see from here in this question, A has completed its execution at this time, this point of time. So this is the total completion time minus what is the arrival time? It has arrived at 0th millisecond. So 8 minus 0 is 8, right? Now coming to B, B completed its execution at 5, and when did it join? At 3, right? So completion time is 5 and it arrived at 3 milliseconds. So it is 2. Remaining time is 2. What about C? The completion time of C is not this one. Just don't be confused. This is 12, right? So this is 12. And then when did it arrive? It arrived at 5th millisecond. 12 minus 5 is 7, right? Now talking about D. So D completed its execution at 21. And then what about its arrival time? Arrival time is 7, right? 12 minus 21 minus 7. Now it is 14. And now finally we are left with E. So completion time of E is 15. And what it is arrival time? 10. 15 minus 10 is 5. Now as you can see from here, these are the individual turnaround time of all these processes. Now let's find out the average waiting time. Average turnaround time will be what? A plus B plus C plus D plus E. So turnaround time of all these processes upon what are the number of processes? 5. So average means you have to divide it with the number of observations. So number of observations here are 5. So what is that? Just calculate it. So here we have 8 plus 2 plus 7 plus 14 plus 5, right? Divided with 5. The result that you are going to get is 36 by 5. And what is the result? 7.2. So this is your final answer. And what was being asked? It was given in milliseconds. So this is actually millisecond, 7.2 millisecond. So I hope you enjoyed the lecture and you understood all the concepts very well. So keep learning and be happy. Thank you so much.